Alright guys, me and Alex here. Today we're gonna present you our subject, the shifted conics. Me, I'm gonna narrate, and Alex, he's gonna write. You're gonna see a lot of his head. Okay, we're gonna admit here now that shifted conics is not the most interesting subject in the world. At the least, it's a very technical subject without any real life example. But it's a very important one, so that's why we're here to try to bring in an entertaining video to talk about this, so you can learn about it. No, we're not going to treat you like a 5 years old. We're going to here to assume that you know what conics are, and other videos going to cover that. So let's get to the basic of shifted conics. Due to some technical difficulty with the cameras, we can't include all what Alex wrote, so that's why we wrote it on the subtitle below. And when you see on a conics equation, when it wrote x minus h, it really means shift h unit to the right. And the same thing goes with y minus k. It means shift k unit to the up. And it applies to the same thing to its opposite, x plus h and y plus k. And guess what does it mean? And yes, you're absolutely correct. When x plus h, it means shift h unit to the left. And when you see a y plus k, it really means shift k unit to the down. So now remember, whenever you see on any conics equation, when you see an x plus or minus h, it means shift h units to the right or left on the graph. And whenever you see a y plus or minus k, it means shift k units up or down on the graph. Remember that, and I should really stop treating you like 5 years old. So now let Alex erase that. Due to Alex's uncertainty of the audience understanding of this topic, so Alex devised this little demonstration to further explain the shifting of conics on an equation to graph scale. So as you can see here that Alex had written an equation of y equal to x, a line on a graph, which he wrote here. Then he devised a new equation that changes to y plus 2 is equal to 2x minus 3. And if you remember correctly from earlier, this means 2 to the down and 3 to the right. And now he draw a new line here. And as you can see from what he'd written, it changes nothing, it just changes where its position is. After we know the basic, now we can delve deeper into the subject of shifted conics. And basically, shifted conics is to take the three major conics, hyperbola, parabola, and ellipse, and shift it along the graph. But the challenging part of shifted conics is to take the equation and derive it to another equation that is useful for helping us to graphing with the basic we learned. And for this video, we'll devise 5 equations that we will show you how to derive it, then we will teach you how to graph it, and therefore you can learn how to shift conics. Hopefully, this video will teach you on how to solve shifted conics problem and teaches you how to spot shifted conics question, and also to teach you a thing called degenerative conics. Degenerate conics are basically conics that fails to make a curve, and we will also teach you on how to spot a degen conics and to how to solve a degen equation. So, the 5 equations we're going to work on is as follows. The first one is x squared minus 8x plus 16 is equal to 2y plus 2. The second one is 4x squared plus 8x minus y squared minus 4y is equal to 56. The third one is x squared plus 4x minus 4y squared plus 24y is equal to negative 4. The fourth one is x squared plus 4 is equal to 9y squared minus 4x. And the last one is 3x squared plus 2y squared plus 18x minus 8y plus 35 is equal to 0. Now let us move on to the first equation. So let Alex write down the equation first. And now we look at this question and see how can we solve this. And it's simple. So we factor out the power of this equation. So on the left side, it will be x plus 4 squared. And on the right side, let's wait, is equal to 2 bracket y plus 2. That's our next step. Now, the job is to make it into equation we can graph it. So we decided to divide half on both sides. So on the left hand side, it will be the 1/2 of x plus 4 squared. And on the right hand side, after we add an equal sign, will be equal to y plus 2. Now, this is the final outcome. 1/2 of x plus 4 squared is equal to y plus 2. Does this look familiar? Yes, it is a conic with the shifted variable we taught earlier. And now we can apply it to the graph. So now let us erase that out and copy the exact same derived equation onto this board. And as you can see from the basic shape of 1/2 of x plus 4 squared is equal to y plus 2, we can conclude that it's a parabola, because a parabola follows the guideline equation of x squared is equal to y, and therefore we can graph it as a parabola that is shifted, and yes, the basic we learned earlier of 4 to the left and 2 to the down. And now let us watch Alex graph that out. And now you can see the final result that this parabola has been shifted from its original origin. And this is the final result from deriving a parabola. Now let's move on to the next equation, shall we? So let us wait Alex to finish writing down that equation first. Now, looking at this equation, how should we solve it? It's actually quite simple. First, let's put the x and y. Let's separate the x and y and factor out the x side, which will result for a 4x squared plus 2x. And on the y side, we will make it as plus bracket y squared minus 4y bracket. And this will all equal to 56. Now, our objective is to turn the equation into the format of x plus or minus h and y plus or minus k. To do that, we will convert the equation to the format of x squared plus 2ab plus b squared, and we'll split it to the purple side of x and the brown side of y. For the x side, we convert it to 4x squared plus 2x plus 1. Note, when added in, it will be 4x squared plus 8x plus 4. That is the format of x squared plus 2ab plus b squared. And due to we can't change the equation, we have the minus 4. This applies for the same thing for the brown side. We do it as y squared minus 4y plus 4 and minus 4. This is to ensure not to change the equation and to keep it the same, but while applying this new format. Now with this, we can now simplify it by factoring out the appropriate section, and it will result a equation of 4x plus 1 squared plus y minus 2 squared, which will equal to 64. And with this, we can even further simplify by making the right hand side to equal 1, so we can see what conics is. To do this, we make the equation into x plus 1 squared divided by 4 squared plus y minus 2 squared divided by 8 squared, and which it should be equal to 1. Now let's move this finalized equation to a fresher area so we can work on it and graph it by erasing it. Judging from the finalized equation, we can tell that this is an ellipse conics. Why will I say that? Well, because the original ellipse formula is x squared over a squared plus y squared over b squared. That's equal to 1. And as you can see, that on this equation, it's a x plus 1 squared over 4 squared plus y minus 2 squared over 8 squared is equal to 1. It's a shifted ellipse. And what we're shifted, and yes, we're back to the basic, we will shift it 1 to the left and 2 to the up. If you think if there's anything weird about this clip, you're probably right, we forget to add an E. But it's okay, we'll add the E back later because our priority is set straight on shifting the ellipse and see what's the difference it makes. And now as this graph is taking its shape, we can see that this ellipse is shifted. Notice the origin in the middle and see how it changes. And this is the shifted conics for ellipse. Now let's move on to the next equation and let Alex finish writing that equation down first. To solve this is actually quite simple as it's very similar to the one earlier. To do this, we separate the x and y again by coloring it purple and brown. The x will be unaffected, just in the bracket, it will be x squared plus 4x. But the y can be factored out with 4, so we can write it as minus 4 bracket y squared plus 6y bracket, and it should all equal to negative 4 because nothing changes. With this equation down, we can use the previous method of a squared plus 2ab plus b squared to help us find what conic it is. So for the x side, it's slightly easier. It would just be x squared plus 4x plus 4 minus 4. So we won't change anything, but still in the format. But for the y squared, it's slightly harder, but the end result will be minus 4 y squared minus 6y plus 9 minus 9 times 4. So it won't change anything, but still following the format. And they will all equal to negative 4. Now, we can even further simplify this to an equation where we can work out what conics it is and how we're going to graph it. To do this, for the x side, we simplified it to x plus 2 squared. It's the same thing, we just get the power out. And for the y side, we do it as minus 4 bracket y squared minus 3 squared, and that will all equal to 36. And note they're all the same, we just simplified them. Now, with this handy simplified equation, we can work it out to a conic-like equation so where we can identify it and plot it. For the x side, we simplified it as x plus 2 squared divided by 6 squared. For the y side, it will be minus y squared minus 3 squared divided by 3 squared, and that will all equal to 1. Does this look familiar now? Now let us erase that out so we can move on to a fresher board and copy that equation down. So as you can see here, while Alex is writing down, that this is a shifted hyperbola conics. Why? Because it follows the hyperbola format of x squared over a squared minus y squared over b squared equal 1. And due to this format, it's a hyperbola that's shifted, yes, we're back to the basic again, 2 to the left and 3 to the up. With this now, we can now conclude that this is a shifted hyperbola, and we can now graph it out. Note that this new point of origin is shifted from the original 0, 0 origin, and this is where the hyperbola graph is now going to build upon this shifted hyperbola graph. Now let's move on to another equation. With this equation, we can now simplify it by moving x to one side and y to one side. To do this, the finalized result will be x squared plus 4x plus 4, and that will equal to 9y squared. The next logical step is to isolate the y squared. So to do this, it's a very simple step. Most people know how to do it. It's just divide 9 on both sides. And the finalized product will be x plus 4 squared, we're simplifying the square too, divided by 9 will equal to y squared. But we don't like that squared sign, so we're going to simplify it by rooting it. To do this, the finalized outcome will be y equal to plus and minus, remember, because we're rooting it, so it has to be plus and minus, so y equal to plus and minus x plus 2 over 3. Now let us erase that and move this to a cleaner board to write it down. And as Alex is writing down here, you will notice that this equation doesn't apply to any of the conics equation. Then what is this? This is our first degenerative conics, a conics that cannot form a curve. And what kind of conics it is? As you can see, the equation is simply followed as x plus 4, x plus 2 over 3 is equal to y. It's just a simple line equation. So this is, as in because of a plus or minus, it's a 2 line. And we can plot it to a graph accordingly. So as you can see this graph forming out, you will see that this is a 2 line that is not forming any curve, so therefore it is a degenerate conic. So let us move on to our last and final equation. So let us let Alex finish writing it down. Now with this equation, how do we solve it? Well, it's actually quite simple, but first let's organize and put x together and y together, then we take out the common factor. The final result will be 3x squared plus 6x, and on the y side it will be plus 2y squared minus 4y. And we have to put in the 35 because nothing should change, so it should be plus 35 and then equal to 0. To simplify it, we will now use the model we used previously all the time, the a squared plus 2ab plus b squared, to help us further simplify it. So on the x side, it will be 3x squared plus 6x plus 9 minus 27. Remember, because we can't change anything. And on the brown side, the y side, it will be plus 2y squared minus 4y plus 4 minus 8. Same thing, we can't change anything. And we have to bring in the plus 35 equal 0. Now, we have to further work this equation, further simplify it to see if it's a conic or degen conic so we can graph it. So to do this, we will simplifying by making the x side to become 3x plus 3 squared, same thing as we did previously. And on the y side, it will be 2y minus 2 squared, and it will all equal to 0. Now let us erase that and move this equation to a fresher board. And as you can see that this again doesn't match up to any conics at all. So therefore it is a degenerative conics. Despite this equation written 3x plus 3 squared plus 2y minus 2 squared equal to 0, it also can mean the other way around, because it can mean 3x plus 3 squared is equal to minus 2y minus 2 squared, and this literally making it a point on a graph. And this is exactly what this is, a degenerative conics that is a point on a graph. And let's graph this out, shall we? And as you can see that while Alex is graphing here, that this is just a point. So now we reach to the conclusion of our video, and we hope that this video has taught you a lesson about shifted conics. We hope that this video has taught you on how the basic of shifted conics and the 5 kinds of problem you will encounter, including the shifted conics for hyperbola, parabola, and ellipse, plus the 2 kind of degenerative conics that you encounter, such as the 2 line and the point. We hope this video has taught you on how to derive an equation and identify what kind of conic it is, and how to graph it onto a graph and see how much it's shifted. So thank you for watching this video, and we hope that you learned something new today. Thank you.